Stay safe, happy learning, say no to theft of electricity for the first time every time. My name is Amarnath. I am a certified energy auditor and I am a retired chief engineer of a public utility distribution company. One of the subscribers had requested me to create a video on diesel generating set. Diesel generating sets empowers our residences and workplaces ranging from the capacity of 1 kilowatt to several megawatts. The diesel engine is the prime mover which drives an alternator to produce electrical energy. In the diesel engine, air is drawn into the cylinder and is compressed to a high ratio of 14:1 to 25:1. During this compression, the air is heated to a temperature of 700 to 900 degrees centigrade. A metered quantity of diesel fuel is then injected into the cylinder, which ignites spontaneously because of the high temperature. Hence, the diesel engine is also known as compression ignition or CI engine. DG set can be classified into two cycle type as 2-stroke engine and 4-stroke engine. However, the bulk of IC engines are used for 4-stroke cycles. These 4 strokes are induction cycle, induction stroke, while the inlet valve is open, the descending piston draws in fresh air, then compression stroke, while the inlet valve is closed, the air is compressed to pressure of about up to 25 bar. Then third is ignition and power stroke, in which fuel is injected while valves are closed. Fuel's injection actually starts at the end of previous stroke. The fuel engine spontaneously and actually starts the piston to move it forward and downwards by the combustion gases. Then there is exhaust stroke. The exhaust valve is opened and rising piston discharges the spent gases from the cylinder. Since power is delivered during only one stroke, the single cylinder 4-stroke engine has a low degree of uniformity. Therefore, for smoother running is obtained with multi-cylinder engines because of engine configuration. For example, 4-cylinder or 6-cylinder. Missing of any one cylinder is analogous to missing of one phase in a 3-phase power supply system. Here is a comparison table of different type of power supply system. Column 1 is description, column 2 is unit, column 3 is combined gas and turbine system, column 4 is conventional steam system, and column 5 is diesel engine power plant. Initial investment combined gas and steam plant is rupees 10,000 to 12,000. For conventional steam plant 15,000 to 20,000, and diesel engine power plant 9,000 to 900 and 500. It is lowest. Thermal efficiency. This is vital. Percentage combined gas turbine and steam turbine 40 to 46%. For conventional steam plant 33 to 36%, and for diesel engine power plant it is 43 to 45%. So you see, with less capital investment, there is better thermal efficiency. Space required is for diesel engine 100%, for combined gas turbine and steam turbine 125%, and conventional steam power plant 250%. Construction time in month: combined gas turbine and steam turbine 24 to 30 months, conventional steam plant 42 to 48 months, and diesel engine power plant only 12 to 15 months. Plant load factor, kWh per kilowatt per year. This is plant load factor per year. So plant load factor per year is for combined gas turbine and steam turbine, it is 6,000 to 7,000 units. Maximum is 8,760 units per year per kilowatt. Conventional steam plant it is 5,000 to 6,000 units, and for diesel engine power plant it is 7,200 to 7,500 kilowatt hour. Startup time is for combined gas turbine and steam turbine 10 minutes, conventional steam plant 120 to 180 minutes, and for diesel engine plant 15 to 20 minutes. Since power is developed during only one cycle, the single cylinder 4 engine is not recommended to apply. Now degenerating set as a system should be considered as its successful operation depending on well-matched performance of components, namely diesel engine and its accessories, the AC generators, the control systems and switchgear, the foundation and powerhouse civil works, and the connected load with its own components like heating, motor drives, lighting, etc. It is shown in this figure. Now, what is the selection criteria? The decision on type of engine which is most suitable for a specific application is dependent on several factors. The two most important factors are power and speed of the engine. The power requirement is determined by maximum load. The engine power rating should be 10 to 20% higher than power demand by the end use. This is because it may be able to prevent overloading the machine by absorbing extra load during starting of motors or switching off some types of lighting system like mercury arc rectifier bulb, or when wear and tear on the equipment pushes up its power consumption. Speed is measured at the output shaft and given in revolutions per minute. An engine will operate over a range of speeds, with diesel engines typically running at lower speeds, that is 1300 to 3000 rpm. There will be an optimum speed at which fuel efficiency will be greatest. Engines should be run as closely as possible to their rated speed to avoid poor efficiency and to prevent buildup of engine deposits and scales due to incomplete combustion. This will lead to higher maintenance and running costs. To determine the speed requirement of an engine, one has to again look at the requirement of the load. For some applications, the speed of the engine is not critical, but for other applications such as generator, where synchronism is important, it is important to get a good speed match. If a good match can be obtained, direct coupling of engine and generator by virtue of flange coupling or any other coupling is possible. If not, then some other form of gearing will be necessary, a gearbox or belt system which will consume extra energy and reduce energy efficiency of the system. There are various factors that have to be considered when choosing an engine for a given applications. These include the cooling system, abnormal environment conditions like dust, dirt, poisonous gas or corrosive gas, fuel quality, speed governing, fixed or variable speed, poor maintenance, control system, starting equipment, drive type, ambient temperature, altitude, humidity, etc. Suppliers or manufacturers' literature will specify the required information when purchasing an engine. The efficiency of an engine depends on various factors, for example, load factor, engine size, and engine type. Diesel engine power plants are most frequently used in small power systems. However, there are some countries in OPEC, oil producing economic countries, who supply electricity at pretty cheap rate or even free electricity to their citizens for as oil is available to them in plenty. The fuel burned in diesel engines range from light distillates to residual fuel oils. Before I proceed further, let me request you to please subscribe the channel, comment and like the video. Most frequently used diesel engine sizes are between 4 to 15 megawatts. For continuous operation, low speed diesel engine is more cost effective than high speed diesel engine. As we discussed in this table, the advantages of adopting diesel power plants are low installation cost, short delivery period and installation period, higher efficiency as high as 43 to 45%, more efficient plant performance under part load. Actually, these thermal power plants and hydel plants do not perform excellent at part loads, but diesel engine plants are works more efficiently under part load. It is suitable for different type of fuels such as low sulfur heavy stock LSHS and heavy fuel oil in case of large capacities. It requires minimum cooling water. It is adopted with air-cooled heat exchanger in area where water is not available. It requires short startup time. So we see several advantages of DG set over other means of power generation. The diesel engines developments have been steady and impressive. The specific fuel consumption has been about 230 to 240 gram per kWh in the decades of 70s, which has now come to 150 grams per kWh. Unfortunately, internets are not providing this updated information. However, as per latest development and research, it is 220 to from 220 grams per kilowatt hour in 70s to 150 grams per kilowatt hour in present time. It is pertinent to note that heating value of diesel oil are 10,000 kilocalorie per kg. So for one generation of 1 kilowatt hour, 160 kilocalorie per kg is consumed. Whereas for theoretically it should be 852. So naturally we see that efficiency is more than 52, 50 to 45 to 50%. Slow speed diesel engine with its flat fuel consumption curve over a wide range compares very favorably over other prime movers such as medium speed diesel engine, steam turbines and gas turbines. With the arrival of most modern high efficiency turbochargers, see here, this is a turbocharger. What does it do? It uses the flue gases, hot flue gases to generate energy, enhancing the efficiency of diesel thermal power plant further. So with the arrival of modern high efficiency turbochargers, it is possible to use an exhaust gas driven turbine generator to further increase the engine rated output. The net result is lower fuel consumption per kWh and further increase in overall thermal efficiency. The diesel engine is able to burn the poorest quality of fuel oils, unlike gas turbine, which is able to do so with only costly fuel treatment equipment. Slow speed dual fuel engines are now available using high pressure gas injection, which keeps the same thermal efficiency and power output as regular fuel oil engine. That's all in this video. Thank you. Stay safe. Happy learning. Please like, subscribe and comment on the video. Once published, the video belongs to you that is the viewers, and it is your solemn duty to comment and like or dislike. Thank you very much.